The average amount of red meat a person consumes each year is 196 pounds with a standard deviation of 22 pounds. So that is the information about the general population. On the average, the amount of red meat consumed by a person is 196 with a standard deviation of 22 pounds. So you can mark that or you can annotate there in your note catcher. So this is your mean. Okay, population mean 196 and the standard deviation is 22. That's the population. You have the population with the mean 196, standard deviation 22. So from there, you draw a sample of size 50. That is the size of the sample. This is your N. You draw the sample of size 50. Okay, 50 individual is randomly selected. We have to find the probability that mean of the sample will be less than 200 pounds. So what you have to find is, you have to find, see, we have to find the probability that the mean of the sample will be less than 200 pounds. Probability that mean of the sample, X bar, is less than 200 pounds. What is the probability? We have to find that probability. Okay, this is quite tricky. You'll be getting some formulas here as we work on this problem. So you have to be very careful when you take the notes. So you have the population. So let's see what is given there for the population. Okay, here you have mean, that is the population mean when you use sigma. I mean mu, that is your population mean. Mean equal to 196. Okay, standard deviation equal to 22. And the size of the sample here, n equal to 22. You have to be very careful here when you work on this. So what they have given, if you look at it carefully, hold on, I just wrote something wrong there. I don't know whether you have noticed that or not. Size is 50, sample size is 50. Here is that, n equal to 50. So here you have the population mean given, population standard deviation given, sample size is 50. So what we know from the central limit theorem is when the size of the sample is greater than 30, the sampling distribution of the sample mean will be normal. So that is what we know from central limit theorem. So we are going to write that. From central limit theorem, I'm writing CLT for central limit theorem, the sampling distribution of sample means is normal. That is what we know from the central limit theorem. So if along the x-axis here in this graph, if along the x-axis here we have the sample mean, this distribution is normal. Now in the normal distribution, if you want to find the probability, now the important thing is here, if you want to find the probability in normal distribution, we need to know for this distribution, for the sampling distribution of sample means, we need to know what is the mean and what is the standard deviation. So your mean will be here in the middle. You know that the mean is in the middle. This is your mean. And for the sampling distribution, we write the mean like this. Mean with the X bar at the bottom like this, or mean with the subscript X bar. This is the mean of the sample means. Okay, so this one, remember this is very important. The mean of the sampling distribution is always equal to the population mean. This is a formula. Mean of the sample mean is always equal to the population mean. And if you look at the population mean, it is 196. So this is equal to 196. That is something you need to know. Because in order to find the probability, we need the mean and we also need the standard deviation. We have the standard deviation for the population. We don't have the standard deviation for the sampling distribution. So the standard deviation for the sampling distribution, we write like this: standard deviation, that is equal to the population standard deviation divided by the square root of the sample size. This is the formula that you need to note. Okay, the standard deviation of the sampling distribution is equal to population standard deviation divided by the square root of n. This is the formula. So if you look at the population standard deviation here, the population standard deviation is 22 divided by the square root of the sample size. Our sample size is 50, square root of 50. So this is equal to, if you use your calculator to divide this, 22 divided by square root of 50, you should get 3.113. I hope you got that. Okay, is that right? Oh, 3.111 and then 3. That's right. Very good. Okay, 3.1113. So these two information, this is the mean for this one, mean, which is 196 is here in the middle, and then the standard deviation is this. Now, if you look at the question, we are asked to find the probability that the mean of the sample will be less than 200 pounds. So along the x-axis, you have the mean. This one, the mean of the means, or mean for the sampling distribution, we saw that it's 196. 196 is here. But in the question, we are looking for 200. So 200 should be somewhere there. So suppose this value is 200. We have to find the probability that the x bar is less than 200. Less than means to the left. So we want this value. Okay, we want this value. We want that value. So if I want to calculate this, this probability is equal to the area under the curve from -infinity up to 200. So I can write like this. So probability that x bar is less than 200 is equal to, in our calculator, we use normal CDF, if you remember. Normal CDF, the lower boundary for the area is -infinity, which is written as -E99 in our calculator. Upper boundary is 200. Mean for the sampling distribution, which is here, that is 196. And standard deviation for this distribution, we have calculated here, it is 3.1113. So if we perform this calculation in our calculator, okay, normal CDF in our calculator, you should get the result, which is 0.9007. Make sure you check that in your calculator.